So hey everyone, I'm the marketing manager at Signify Technology. I'm going to introduce the next speaker. So who I've got here is Piotr. He is a notorious engineer and software gardener who mostly works in Java Gardens and sometimes in Scala. So I'm going to kick off his talk checking out JVM. Off you go.
Hello, people. I'm going to talk about basically JVM as well. The idea was to talk about JVMs between 12 and 16, but I've decided to broaden the scope a tiny little bit. So we're going to cover slightly 9 and 10 and 11 as well. So let me share my screen. And here it goes, I believe. So this is it. So who am I? Just by looking on my shirt, I mean, first because of the pattern, second because it's ironed only in the front, you can tell I'm a software developer, and that's correct. I'm a software developer, but I entitle myself as remote freelance software gardener. I blog every now and then, and I post my stuff on softwaregarden.dev, and I also work as a trainer for a few companies, one of them being Cementis. The idea of this talk is basically what happened to me on my holiday, because I'm mainly programmed in Java, but sometimes I do stuff in Scala or Scala.js. But this is actually how it looks like, right? So here you are a proud Scala developer, but in the background there's always this Java thingy to run your stuff, right? So this is it. Whether you like it or not, I think we cannot escape from that. So the idea for this talk is to get familiar about the changes that happen here in the background, nothing that changed in Scala itself or will be changing. Okay, so I also have a question to you, who you are. And of course, I guess we are not going with entire bios, but if you could please enter into the chat what version of JVM or JDK you're using in the production, that would help us a little bit to find out who we are, and possibly answer any questions. And if you have any questions as well, please enter them in the chat, so we'll answer them during the Q&A here or later in the spatial chat. Okay, and please remember, I might not be from Oracle, but still, this is my safe harbor statement, so don't trust strangers on the internet. They might be mistaken. So Java, what actually is now happening to Java? Because I assume, let's say that you're running still Java 8 in production, or you compiled to Java 8, and you might not be familiar what happened since then. So what happened is now Java is released every 6 months. So a big release, major version is released every 6 months, once in March. So in March, we're going to see Java 16. And then in September, we're going to see Java 17. And so the story goes, pretty much like Ubuntu or other stuff. Java now has a concept of preview features. A preview feature is something that is already shipped, kind of delivered in a major Java version. Yet it requires special switches like -- enable -- preview, or so during compilation and during runtime. So you double check you're not shooting into your whatever part of your body. And the idea is that it's generally quite ready, but it still might change because of the feedback. So the usual routine is that features are undergoing two previews, because one would be not enough. It would basically mean only 3 months. And every now and then we happen to have LTS, which stands for long time support version. And actually, I'd like to repeat what Ron Pressler keeps saying, that LTS is actually not a technical term. It's a business term. It's like a promise about, that someone will be there to fix bugs for a given version, and so on and so on. Technically, LTS and non-LTS versions aren't different when they are released, right? So there's no like more features, or they are not more stable or whatever. So it's LTS, it's about support. But if your application, at least this is what happens in Java world, if your application can run on the latest major version, this is generally what you should be doing. You shouldn't be postponing this. But LTS is a kind of fallback if you can't do that due to whatever reason. So changes to the Java language we've seen over last few years and there's some changes because we are not able to cover all of them in 30 minutes. So we have now private methods in interfaces since Java 9, which kind of makes them more and more similar to traits. And in Java 10, we have we have type inference for local variables. So you don't have to, in Java, you don't have to declare like the type of the variable. If it's a local variable, that is, it's not a field or Java parameter, sorry, method parameter or a return type, then the compiler may infer type for you. And this gets useful quite many times because actually the type system of the Java compiler is richer than the language or permitted by the syntax of the language. Since Java 14, we have switch expressions, which kind of look similar to, for example, match or when in Kotlin, but they're not exactly the same. Nevertheless, this is like we now have not only switch instruction in Java, but also switch expression, so an expression that results or yields a value. Since Java 15, we have text blocks, which basically allow creating like a multi-line string returns. So we don't have to like, add \n or whatever, or read that from external file. We can now have multi-line text blocks directly in the source code, which is kind of useful, especially for the SQL people, or when we are testing, for example, various REST responses or whatever. Since Java 16, we are going to have, which should be like in a month and 3 days, I believe, we're going to see records in Java. Records being somewhat similar to case classes, but they are not exactly the same. And this is really, really a long shot. So please don't, like, we can compare them, but they are nowhere near, I think. But basically, they are Java's way or Java's answer for immutable data carriers. So the records are going to be like a new data type, pretty much like enum was for Java 5, for example. And they're going to be immutable. By default, they're going to have equals, hash code, constructors, toString, and accessors, because they're not going to be Java beans sensu stricto. They're not going to have the getters. And since Java 16, also we're going to have the first implementation, I mean, after preview features, of pattern matching with instance of. So it's still not working with switch expressions, and we still don't have any deconstruction or extracting variables out of objects. Nevertheless, now with instance of, we can save basically one line since Java 16, because we don't have to cast the type again after matching with instance of. And this, I don't know if it's going to be official or like a regular feature in Java 17. For now, in Java 16, we have sealed classes. Actually, this is for sealed classes and interfaces. It's a second preview in Java 16, and this is not working exactly as we have that in Scala, for example. Mainly because in Java, we don't have a concept of, few public classes or interfaces in one source file. Nevertheless, we are able now to seal our inheritance tree to make sure that, for example, if we are like a library vendor, users don't sneak their implementations or extensions. And the changes to the JVM, and I hope this is what you came for this talk, that we have compact strings in Java 9. Well, actually, I am able to show you that in the source code. So let's go for a string, and in the string class we had this value, and until Java 8 this used to be an array of characters, and since Java 9 this is an array of bytes, which means that if we are, let's say, in the ASCII range, or if we speak like Western languages, we don't have to waste every second byte because of that. For example, my name could be written only with 5 bytes. So we don't need 10 bytes for that for UTF-16. And there's just one more extra field coder, and it says if it's Latin 1 or UTF-16 like in the past. So there is no change needed. You don't even need to recompile your code. You just run your code, and this means that, I mean, you will save by running such code. If you have a lot of Latin 1 strings, you will save half of your heap, basically, just by switching to Java 9, assuming you can do that, of course. Okay, so compact strings, we also have class data sharing since Java 9, and this got implemented, and improved over various versions. And this means basically faster starts or faster boots of applications, because now the JVM doesn't have to scan all the jars or the whole class path every time you start your application. Now you can provide the result of this scanning. So, I mean, this is like a live for children, but we can do with that for a minute. So instead of doing this story with checking which class is in which jar and so on and this mapping, we can do it only once, dump the result to a file, and then when starting the JVM, we'll use that at this machine or at other machines, provided we didn't change our class path. Since Java 10, Java is more container aware, so to say. So, for example, it can spin up a proper number of threads in the background because of the number of the processors assigned. As far as I can tell, this was backported to Java 8. But first it was introduced in Java 10. Since Java 11, we also have Java Flight Recorder for masses, which is very nice, like production level and low overhead profiler. So if something is going wrong, possibly with the application, and you cannot replicate that like locally or in any pre-prod environment, and you'd like to profile your application, how it really behaves in the wild, you can use now Java Flight Recorder, which basically became like open source or freed. And we can gather like a result of the flight and then use it later, for example, Java Mission Control, to see what was happening to our application. We have new garbage collector, Epsilon GC, which is very interesting kind of garbage collector because it doesn't collect the garbage. I mean, it's very useful if you have like if you're sure your application won't, for example, consume all the available memory, or if you need that for benchmarking, then Epsilon GC might be quite handy. We have various improvements, not only in 12, but I think the most significant ones were available since or in Java 12. So there are various improvements to G1. G1 can now give the memory back to the operating system when it's not needed, or G1, since version 12, maybe got backported, I'm not sure, can abort very long collections if it's like a cache miss hits, basically speaking. So like it doesn't freeze your application for longer than needed. Now G1 can detect such situations. And we have also now, because this Java Flight Recorder was basically like offline, an offline thingy. So we had to record this file, download this file, and then analyze this file. Since it's Java 14, we can consume these events like in a near real time. So JFR can send these events and we can consume them, and based on that, react or do something, whatever it's needed. We have also helpful null pointer exceptions. So instead of just having Java lang null pointer exception, of course, I know in Scala you never observe null pointer exceptions because you have a proper option and it's not like optional, which is not a monad and blah, 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 yada, yada, yada. Nevertheless, sometimes NPEs happen, right? So since Java 14, there was an option to be enabled, and since Java 15, it's enabled by default. So whenever you try to consume something and that something happens to throw an NPE, you will find precise information where it happened and why it happened. It won't tell you like who created the NPE or who like introduced it, but nevertheless, it would tell you exactly in which line it happened. And not only that, but also like for which method call and so on, because we could, for example, could have a few method calls in a single line, and then it was problematic to find out in this one line chain which call caused the null pointer exception. Now it's no more the case. And I think maybe the coolest change among all of these is the ZGC and Shenandoah, which are low pause garbage collectors, and they got introduced officially in Java 15. They at least Shenandoah got backported to Java Java 11 and maybe even 8, but I'm not sure if these are like proper, like the latest versions, just as in Java 15. And they still receive more and more features in the new Java versions and versions to come. Basically, if you don't care about general throughput as much as you care about having really short stop the world pauses, I mean, you should really take a look at one of these, ZGC coming from Oracle and Shenandoah coming from Red Hat. And in Java 16, we're going to have elastic metaspace. For example, if it's discovered that the metaspace is going to be like needlessly big in the future, again, Java will give this memory back to the operating system as one of the features. So there are more changes to Java in general, and sometimes they are difficult to classify whether there are changes to the language itself or changes to the underlying runtime. Sometimes there are changes just to the ecosystem or GDK. So as you may know, and you probably know, we have modules since Java 9 coming from Project Jigsaw. This caused like this pesky warning we see many times, like illegal access occurred because someone was trying to do, so basically reflection or trying to get, as the name says, illegal access to some internals of classes they shouldn't be, or objects they shouldn't be using. And this, what happened in Java 9 and 10, because of the Project Jigsaw, many modules, or 6 to be precise, got excluded to dependencies which were disabled by default but still available. But since Java 11, except Corva, they are all externalized. So now if you need, for example, I don't know, JAX-B or something like this, you need to add a dependency to SBT, Maven, Gradle, or whatever you happen to use. And they also, when it comes to mindset, maybe the biggest change is this, that finally Java, once it's identified that something is nothing more but a ball and chains, then it gets removed, basically. So until Java 8, at least in theory, Java was backward compatible. Of course, not in all cases, but in like a majority of time, you could be pretty sure that if you wrote something in Java 1 or 2, it will run up to Java 8. But however, if you are using, for example, these modules which got removed or making some other calls, now it might happen that your program won't run in for example, Java 9. One of the greatest examples is that various methods are removed from scan-safe. What I personally like is this. I think there is a slight shift, an ongoing shift toward immutability. In Java, one of the examples is immutable collections. Of course, in Java, we don't have immutable collections by type, so we are not able to tell by the class or interface that the collection is immutable. We just get like a runtime exception, which is quite unfortunate, but I don't think it's going to change. Nevertheless, now we have, like, for example, list of or set of methods which allow us to create easily immutable collections. We have also unified logging, so just one X or -X log, and then we can log whatever we want to. I mean, there's no special logging syntax anymore for garbage collector or for jitters, for jitting or whatever. Like, everything is logged, or the definition of logging is done using a single and unified format. And also we have JShell. Finally, Java has a repo. We can also run now programs without compiling them, provided they're in a single source file, roughly speaking, and so on and so on. Of course, there are also, like, let's say, negative changes to the garbage collectors, and negatives in the sense that something is not only added but also removed. So, for example, since Java 14, we don't have any more concurrent mark sweep. So what will come to in the future to Java? Well, I'm not able to tell you that exactly, and I'm not sure if there's a single person in the world who can tell you what exactly will happen to Java in the future and when exactly. But I think there are of course people who know more, but I can also tell you a few things. So we are going to have Project Loom. And the name changes. Sometimes these are like with threads, sometimes they're called fibers, and so on and so on. So I just call them beta threads. So we're going to have threads which are not going to be like one-to-one bound with the OS threads. Therefore, they're going to be much lighter. And instead of having like thousands of them, we'll be able to have millions of them. because why not? And we'll be able to get to this approach, for example, with one thread per request, or threads could be so lightweight that we could be using them just, for they could be like a single-use thread. No need to reuse them. Project Valhalla is going to also give us more cool stuff. And I believe this is the current name, the primitive object. So for example, if we're going to keep an array of objects, the header of the object is not going to be repeated. We'll be able to have, for example, a single header for the whole array, and therefore the whole array will consume less memory. Also, more goodies will come from Project Amber. So not only like stretch expressions, for example, or instant pattern matching with instance of, but we're going to have most probably like proper pattern matching, for example, with deconstructing objects, extracting internals, and so on and so on. So as you can see, Java is also following this path of allowing more and more functional style in programming. And Project Panama is going to turn Java to be like more native aware and more foreign friendly. So I think this is especially important for the people who still need to run various libraries or frameworks which cannot be updated after Java 8 or actually after Java 9 came live, because they need to use stuff which got deprecated or removed from some it's unsafe. So Project Panama actually is about to replace that. So we're going to have like more native features of our operating systems, like foreign memory access, and so on and so on. All right, so I think we still have time for a short demo, because why not? So let me, because I like to show you these garbage collectors, because why not? So I have, Jarek has helped me to create this simple, I call it GC quasi benchmark. It's not a proper benchmark. So if you're like doing your PhD right now, just don't quote on me. This is not a proper benchmark, all right? What it does, it does what we shouldn't be doing. So it just creates garbage, right? This project creates garbage. We should be reduce or eliminate the number of garbage we create, the amount of the garbage. And so as you can see, it makes the GC busy. And now I'm able to run it with various garbage collectors. So first I'll run it with G1, which is the default now after Java 9. And as you can see, I'm recording, I'm using this Java flight recorder to record actually what's happening to my, or with my application. I'm recording this to this g1.jfr file. And yeah, I mean, the whole execution of this program took like 14 and a quarter of the second. This is like a, basically speaking, like a wall clock time. Now I'm going to use the parallel GC. Parallel, yep, let's run it. Yeah, as you can see, it's a parallel garbage collector. All right. I mean, before the talk, it didn't take so long because I wasn't running Zoom. And now with Zoom, it took, like you see, almost 21 seconds, quite long. And now let's run it with ZGC, if I'm not mistaken. Yep. Oh, sorry, I made a mistake. Yeah, of course, there should be time. Oh, fatal error. What's happening? Oh, whoa. Let's check what Java version I have. So see, I was running Java 11. All right, so let's run it, of course, using 15, Java 15. Let's run it again. Yep, it's running now. And as you can see, it took like 7 seconds, a bit more. And now let's run it with Shenandoah. Okay, and yeah, like almost 6 seconds. And now I need to go back, I think, for Java 11. Because I'd like to run this concurrent mark sweep, right? Just, to compare the numbers. Okay, it's running, still running. Hello, Mr. CMS. Maybe there's a reason why they actually removed that. Okay, 15 seconds, not that bad. We saw worse results. So now let me run Java Mission Control, which is basically a program allowing us to read the results. I mean, these Java file recorder files. And yeah, I mean, the Zoom is interfering now. Maybe let's do it like this. Okay, so I can also see what I'm doing here. That would be quite useful, I think. Okay, so as you can see, CMS, it didn't take as much time as, for example, Perl OGC. But as you can see, it has this red exclamation mark next to garbage collections, telling us that there's something wrong with the garbage collecting. And these are the pauses. As you can see, everything nicely visualized. And now I'd like to show you, because we'd like to focus on this longest pause. So as you can see, the longest pause, it was quite at the beginning. It was like over 300 milliseconds, of course. Then it goes below, and after it's warmed up, it's like 130, 140 milliseconds. Not that bad. Let's see how parallel garbage collector is behaving. I mean, it's not auth anymore. I need to rename the file because it also got like removed in Java or deprecate Java 14 or something. Nevertheless, you see the longest pause is like almost 300 milliseconds, and then it goes below but stays over 60 milliseconds. So still quite blocking, I'd say. Let's check this G1, which is a default one after Java or since Java 9. And again, there's this red exclamation mark. But as you can see, the pauses are not that bad. I mean, they are like over 100 milliseconds, and then they go below, and then they go even better. And there's a nice memory usage pattern, as you can see. And now let's check ZGC. And ZGC, you can see no red exclamation mark here. Interesting. And the longest pause is, that's correct, ladies and gentlemen. This is like less than 1.5 milliseconds. So it's not tens or hundreds of milliseconds. It's like, after this this is like sub-millisecond pause. So this is how good it is. And let's check Shenandoah. And again, no red exclamation mark, which means things are pretty good. And for this particular run, the longest pause took just slightly above 0.5 millisecond, and the other ones were below 0.5 millisecond. And then, 200 microseconds. So see, if you care about short, stop the word pauses, and you don't even need to recompile your code, right? You can go with the same jars you already have. But if your manager or your shareholders or whatever, they're complaining that we have these freezes of this application, maybe you should switch from this and maybe from G1 as well, and go for ZGC and Shenandoah. But I need to warn you, if you're batch processing and if you care about the general throughput, these are not for you, because they do stuff in parallel, and because of that, as we all know, they consume at the end of the day more CPU power. So if you have to, do like bank reports or whatever, probably you'd like to stick to one of these, like G1, for example, or parallel. But if you care about online processing, then maybe you should take a close look at Shenandoah and ZGC. There's one more thing I'd like to show you, and it's this application class data sharing. Okay, so as I told you, it's a kind of cache actually. So it saves time, it saves precious milliseconds, sometimes even seconds. But we're not talking about Spring, right? Sorry. Yeah, what it does, first I'm creating, and this is using these new features from Java 13, I'm creating in a single go application class data sharing archive, zip here, for this dynamic JSA. Then I'm running for without it, I mean, with this class data sharing disabled totally, then I'm running it using only the class data sharing archives from the JVM or /JDK itself, because since Java 12, I believe, your JDK has to be shipped with that, as the specification says. And then in the last run, we are going to use like this, I mean, cached CDS for everything. So for the JVM, JDK, and our application as well. And again, please remember, this is not a proper benchmark. It's just like an illustration or something like this. So let's run it. Which version do we have? Java version, it's 11. We have to use at least 13. Let's use 15. Okay, again, you don't need to recompile your code. It's about runtime. It's not about compilation, right? So let's run this script. Should I have? Yes. Okay. So this is how long it took. So it took like 3/4 of a second to create this archive. Then running without any cache, it took like 435 milliseconds. Then running with caching enabled just for the JVM, it took slightly below 400 milliseconds. And then when we also enabled the cache for our application, which I remind you is a simple single class, single method hello world application, nothing more, we got even below 300 milliseconds. So the richer your class path is, the more classes, the more jars you have on your class path, then you're going to benefit more when it comes to startup times of your JVM. Okay, so let me go back to the slides. Yeah, if you'd like to read more about this project, please go to OpenJDK projects page. If you want to know more about these previous versions of Java or how they run and so on, pretty much for every version, I do like a deep dive, like 2 or 2.5 hours. You can see all these talks recorded and available for free on YouTube on my page. Just click and you'll see that. And please remember, for every speaker at every event, even if it's a remote one, please provide your feedback in any form. But I encourage you this time to fill this little anonymous, at least anonymous from my point of view, Google form. Paul, it has 4 or 5 really short questions. It will take you a minute, maybe 2. And that's it. Thank you very much for attending this talk. I hope you'll be able to switch to newer JVM versions to benefit from the better performance, to spend less money for your hardware or your cloud providers, and then eventually also generate less CO2 and stuff. So here's the link for the source code if you're really interested. Here's the link for the slides. You can also follow me on Twitter if you're interested more in about Java and what's going on. Back to the studio.